Saturn's rings are surprisingly young, forming within the last 100 million years. Saturn is the sixth planet from the Sun and the second largest planet in our solar system. Adorned with thousands of beautiful ringlets, Saturn is unique among the planets. It is not the only planet to have rings, made of chunks of ice and rock, but none are as spectacular or as complicated as Saturn's. Like fellow gas giant Jupiter, Saturn is a massive ball made mostly of hydrogen and helium. Surrounded by more than 140 known moons, Saturn is home to some of the most fascinating landscapes in our solar system. From the jets of water that spray from Enceladus to the methane lakes on smoggy Titan, the Saturn system is a rich source of scientific discovery and still holds many mysteries. The farthest planet from Earth discovered by the unaided human eye, Saturn has been known since ancient times. The planet is named for the Roman god of agriculture and wealth, who was also the father of Jupiter. Saturn's rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made of billions of small chunks of ice and rock coated with another material such as dust. The ring particles mostly range from tiny, dust-sized icy grains to chunks as big as a house. A few particles are as large as mountains. The rings would look mostly white if you looked at them from the cloud tops of Saturn. And interestingly, each ring orbits at a different speed around the planet. Saturn's rings are only about 100 million years old, meaning they formed long after the first dinosaurs and mammals walked the Earth. NASA's Cassini spacecraft made daring dives between Saturn and its rings during its grand finale, providing groundbreaking data that revealed Saturn's rings are only 10 to 100 million years old, much younger than the planet itself. Precise measurements of Saturn's gravitational field, achieved during these maneuvers, allowed researchers to determine the ring's relatively low mass. The cause of the ring's formation remains unknown, though theories include a catastrophic event like a collision. Cassini's data also offered insights into Saturn's interior, including the depth at which uniform rotation begins and the size of its core. During NASA's Cassini spacecraft's grand finale, the craft daringly dubbed between Saturn and its rings, gathering groundbreaking insights about the planet and unveiling the unexpected youthfulness of Saturn's rings. Recent studies reveal that these majestic rings are much younger than Saturn itself, likely forming in just the last 100 million years. Initially, Cassini orbited Saturn outside its rings, which complicated efforts to distinguish the gravitational pull of the rings from that of the planet, a crucial step in determining the ring's mass. Scientists had long theorized that the ring's mass could reveal their age, but precise measurements had to wait until Cassini's final, bold maneuvers. As Cassini dove between Saturn and its rings, researchers meticulously monitored a radio link between the spacecraft and Earth. This allowed for an accurate measurement of Saturn's gravitational field, unobstructed by the influence of the rings, as explained by study author Luciano Ias of the Sapienza University of Rome. Upon finding that the rings possess a relatively low mass, scientists concluded that Saturn's rings are only 10 to 100 million years old, far younger than Saturn, which is estimated to be 4.5 billion years old. Ias noted, there were already clues from Voyager and Cassini measurements that the rings had not formed with Saturn, but now we have much more concrete evidence, which was only possible to obtain during the final phase of the mission. Saturn's mysteries. While these findings pinpoint the age of Saturn's rings, the exact cause of their recent formation remains a mystery. A catastrophic event like a collision looks to me the most obvious explanation, but there may be problems with that too, Ias stated. He added, the origin of the rings has to be put in the broader context of the dynamics of the Saturnian system. There are colleagues who think that even the inner moons of Saturn are young, and they are migrating outward. Cassini's close passes didn't just reveal the ring's age. They also provided deeper insights into Saturn's gaseous interior. Saturn, primarily composed of hydrogen and helium, has a unique atmospheric rotation where the outer layers move faster than the inner layers. With this new data, researchers were able to quantify this difference and discovered that uniform rotation begins at a depth of about 5,592 to 6,214 miles, 9,000 to 10,000 kilometers, below the surface. The study also sheds light on the size of Saturn's core, revealing it to be composed of heavy elements and accounting for about 15 to 18 Earth masses, or 15% of Saturn's total mass. According to Ias, understanding the core size could provide key insights into the formation of Saturn and its moons. Check the links in the description down below.